Okay, so we're going to have a look at this projectiles question from 2019, and the first thing we always want to do when we have a projectiles question is we want to get down the equations for v of x, s of x, v of y, and s of y. So if we have a look at the velocity vector up here, we have a velocity of 40 at an angle of alpha, and so what we're going to do is we're going to split that up into 40 cos alpha in the horizontal direction and then 40 sine alpha in the vertical direction. And so when we get that down, we can then start forming our equation. So the horizontal velocity v of x will always be 40 cos alpha. So the velocity in the horizontal doesn't change as the question goes on. So if we pick a point later in the question, so for example here, it will still have a horizontal velocity at that stage of 40 cos alpha. The distance formula then in the horizontal direction, s of x, is equal to that speed, 40 cos alpha, multiplied by the time that it's been traveling for, so 40 cos alpha times t. Vy, the velocity in the vertical direction, originally is 40 sine alpha, but then as time goes on, gravity has an effect on that vertical velocity, and so we have minus g times t. And then for our distance in the vertical direction, or our height, let's say, in the vertical direction, we have s of y is equal to 40 sine alpha t minus a half gt squared. And so once we get these four formulas down, we can then start reading the question and seeing what the question is about. The question asks us to find the value of alpha at the angle of the projection, and we're given a couple of bits of information. We're told that the cliff is 30 meters above the ground, and we're also told that the maximum height is 42 above the ground. Now, it's 42 above the ground, but it'll only be 12 above the point of projection. So what we're going to do is we're going to find the time at which this maximum height occurred. And the time at which a maximum height occurred is where the vertical velocity is equal to 0. So we're going to let v of y equal to 0, and then we're going to sub this time into the vertical height formula, s of y, and let that equal to 12. We know that at that particular time, when the maximum height was achieved, the particle was 12 meters above the point of projection. So we're going to let 40 sine alpha minus gt equal 0. So remember, this is v of y, and we're letting this equal 0. And we're going to get t on its own, so we're going to say 40 sine alpha is equal to gt, and then we'll divide by g to give us that the time is equal to 40 sine alpha over g. We're going to sub this time in for t into the vertical height formula and let that formula equal 12 and solve for the angle alpha. So 40 sine alpha t minus a half gt squared is equal to 12. We know that the time is 40 sine alpha over g, so we're going to sub that in. We're going to tidy this up. We can see that 40 multiplied by 40 will be 1600, and then we have sine squared alpha over g. And then tidying up the second part, again we have 40 squared will be 1600. We then divide that by 2 to give us 800. And the g will be squared to give us g squared, and that can cancel with the g above to give us the g on the bottom. And so we have 1600 sine squared alpha over g minus 800 sine squared alpha over g is equal to 12. I'm going to multiply across by g, and then I'm going to subtract the 800 sine squared alpha from the 1600 sine squared alpha to give me 800 sine squared alpha is equal to 12g. I'll divide both sides by 800 to give me sine squared alpha is 12g over 800. I'll get the square root of both sides to give me that sine alpha is equal to 0.3834. And then to find the angle alpha, I do the sine inverse of 0.3834, and the angle is 22.54 degrees. So for part 2 of the question, we're going to carry forward our formulas. And we also now know that alpha is equal to 22.54 degrees, and we're going to use that. We're asked to find the horizontal range of the particle. And so the horizontal range can be found using s of x, and it's the distance from the point of projection horizontally out to this point C where it lands. Now we know that at that particular moment in time when it lands, s of y is equal to minus 30. So we're going to let s of y equals minus 30, find the time that that occurred, and then sub that into the s of x formula to get the horizontal distance travelled. So s of y equals to minus 30. We're going to sub in our value for alpha, which is 22.54, and then we're going to multiply this out and tidy it up to get a quadratic 4.9t squared minus 15.33t minus 30 equals 0. We're going to use the minus b formula, or the quadratic formula, to find a value for t, and t is equal to 4.49 seconds. So the negative value that we get in the minus b formula, we can discount that because t obviously stands for time. And so the particle landed at 4.49 seconds. And what we want to do now is we want to find the horizontal distance, s of x, travelled in that time. So s of x is equal to 40 cos alpha t. We know that alpha is 22.54, and we know that the time is 4.49, and we just multiply this out and we get s of x is equal to 165.88 meters. So the final part of the question is to find the speed of the particle as it hits the ground. So as this particle hits the ground, it has both a vertical velocity and a horizontal velocity. Now we know that the horizontal velocity as it hits the ground is 40 cos alpha, so that remains the same as it was when it was projected at point A. The vertical velocity is 40 sine alpha minus gt, and so we need to plug in a time into this to find out what was the vertical velocity when it landed. Now we already figured this out in the previous part of the question, and we know that that time was 4.49 seconds. So we want to find the speed of the particle after 4.49 seconds. So we know it's made up of the horizontal component and the vertical component. The horizontal component is 40 cos alpha, and the vertical component is 40 sine alpha minus gt. We're going to sub in 22.54 degrees for alpha, and we're going to sub in a time of 4.49 seconds. And we get that the velocity at that particular moment in time, so 36.944 in the horizontal direction and minus 28.667 in the vertical direction. Now remember, when we're asked to find the speed, they're asking for the magnitude of the speed at that time. And so the magnitude is found by getting the square root of the horizontal component squared plus the vertical component squared. So that's going to be the square root of 36.944 squared plus minus 28.667 squared. And we get a speed of 46.76 meters per second.